Hello, we are students from the IUT of Périgueux, and today we are going to show you how to extract different components from commercial milk. We will start with practical work 1, which involves the lipid extraction from milk. First, we turn on the water base of the rotary evaporator and place a silica plate in the oven to dry out. Next, we take all milk and place it in a centrifuge tube. We add trichroacetic acid to the milk, followed by methanol. And chloroform. Then we blend. We centrifuge for 2 minutes our tube in order to separate the milk into 3 distinct phases. We carefully remove the lower lipid phase using a Pasteur pipette and transfer into a flask. The rotary evaporator permits to evaporate the chloroform on the lower liquid phase at an indoor temperature and obtain lipid residue.
To observe the components of the milk, we do a layer chromatography. We add chloroform to the lipid residue we weighed before. This is the milk control test. To realize some control tests to compare the milk during the chromatography, we take butter and melt it in the oven, and then we add chloroform and mix it. We remove the upper part with a pipette. This is the butter control. For oil control, we mix 0.5 grams of oil in chloroform. Finally, we use a pipette cone to lay each control test onto a thin layer chromatography plate, adding a cholesterol control test. Once the migration has occurred, we remove the plate from the tank and spray it under the hood with the H2SO4 solution. Then we put the plate in the oven. Following the chromatography, we note the presence of 4 main lipids.
For the second part of the practical work, we extract the proteins. We put distilled water in the first cuvette to calibrate the 20 cuvette at 2.5 milliliters. A solution is prepared by adding dextran blue, vitamin B12 and tartrazine. This solution is added to the chromatographic column, which is recovered after passing over the gel in the 20 cuvette. This step is the calibration of the chromatographic column. We found the absorbance value of dextran blue and vitamin B12, so we measured the missing absorbance of tartrazine, which is 426 nanometers. Correction, the absorbance at the 3 wavelengths of the dyes is measured. Subsequently, we prepared 5 standard solutions of different BSA concentration to create a Bradford calibration curve, with each cuvette containing Bradford reagent and a different volume of water. After preparing the solution, we mixed each cuvette and left them aside for 15 minutes.
In the meantime, we mixed trichroacetic acid with milk in a centrifuge tube and centrifuged it, recovering the yellowish supernatant as the white pellet remained at the bottom. After doing this, we measured the absorbance of the Bradford cuvettes. We then took the supernatant, placed it in a cuvette, added Bradford reagent, let it rest for 15 minutes, and measured the absorbance. We saw that the highest absorbance of the blue produced was the 9th cuvette, so we calibrated 9 cuvettes because the proteins will come out at the 9th cuvette. Once the milk is placed in the chromatography column, add water until the mixture is completely eluted. We collected 9 fractions of 2.5 milliliters. Then we collect the 9th tank containing the proteins with Bradford reagent and wait 15 minutes. We therefore measure the absorbance.